All right, now I'm going to do selected problems from the last unit. So one of them is actually out of chapter 2 on writing the equation of the line. That's from section 2.3. And so for this one, you can use the point slope formula, which you will have to know if you're going to use that. And then the ordered pair is like a particular point. So you're going to plug in the -8 for x1 and the -5 for y sub 1. And -3/4 goes in for the slope. So it'll be x minus -8. And then over here it'll be y minus -5. And I put negatives all over the place because that's probably the hardest thing about it. And so then before you distribute the -3/4, x minus a -8 is the same as x plus 8. And y minus -5 is the same as y plus 5. So take care of that first, then distribute. And take your -3/4 times 8. You can use your calculator to do it if you need help with that. So -3/4 times 8 would be -6. And then you want your final answer in slope-intercept form. So, after we plug in, we have an equation for the line. All this work is just getting it in slope-intercept form. And there you have it. Okay. Now, those of you that like to use y equals mx plus b from start to finish, I'm okay with that. Okay, so if you prefer this method because, remembering y equals mx plus b it's easier to remember, then you need to know that m is -3/4, that you would put the -8 where x is and the -5 where y is, and you would be finding what the b value equals. So some of you do it this way, and that's great. If you did that, you'd wind up with -3/4 times a -8 would be +6. And then you'd have to subtract 6 from both sides to get your b value to be -11. And then you'd come back in and replace the m and the b in the general formula y equals mx plus b. So you'd get to the same ending point. So just whichever one of these you're most familiar with would be the one to use. You need to know the formula though. Okay. All right. And then another problem I want to do comes from, let's go ahead and do the chapter 8 problems we've been working on. Down near the bottom on the study guide, it says to solve a nonlinear system of equations, and this is one of the examples. So we have a system of equations. Okay, here's the example. This would be from section, I think 8.4 is where this would be, right? And this is chapter 8. I believe this is the 8.4 stuff. All right, so for this one, okay, we were working on this. On this one, what you might do is maybe get the x by itself here so that you can use substitution. So that bottom equation becomes x equals y plus 1. And so where the x is, okay, I'm going to wind up replacing it with y plus 1. Okay, so right here, where the x is, I'm going to be putting the y plus 1 in place of it. So that would be 5y equals, and then right there where the x used to be, I'm going to put a y plus 1. It'll need to get squared, minus 1. All right, so that's one way to do it. I'll show you. You could also do the addition method if you're careful and understand how to do that. All right, so here, what I would have to do is multiply the y plus 1 times itself, okay? So FOIL that out. Be thinking about this as y plus 1 times itself. So you get a y squared plus 2y plus 1, and there's a minus 1 on that side already, and then on the left side we have 5y. Now this turned out to be quadratic, so I'm going to need to get a 0 on one side. Okay, so I'm going to subtract 5y from both sides to get a 0 there. And then I have y squared minus 3y, and then the 1 minus 1 wound up canceling out. So that's that's it. I've got y squared minus 3y is equal to 0. So now I have to finish solving that. See, the whole point of this step right here is that now we have an equation that just has y in it. So from here to the bottom, I'm just trying to find what the possible y's are. So y squared minus 3y equals 0. So I can factor the y out, and I wind up seeing that y could equal either 0 or 3 to make that true. So then what you're going to do is you're going to say, well, if y equaled 0, you're going to figure out what would be the x that would correspond to that. So if y equals 0, okay, you're going to plug the 0 in, and you're going to determine what the x would need to be. So we're going to go all the way back up here to this equation, and we're going to say if y equals 0, x would equal the y plus 1. The 0 is going to go there. Okay, so x would equal 0 plus 1, which is 1. All right, so that would give you one ordered pair, x1 while y is 0. Then say, okay, if y equals 3, then x would wind up equaling 3 plus 1, or 4. And so you'd have the ordered pair 4, 3. Okay, so you get those two ordered pairs. All right, and so remember on these nonlinear systems, you know, you might have a parabola and a line, you might have a circle and a parabola, and, you know, things could be, you know, like 4 points of intersection. So you just have to keep your work organized and make sure you're getting both the x and the y for each point. All right, and then another objective said to graph the solution set of the system of inequalities. So let's try this one. So here's a system we're given. This would be 8, 5. If we had y is greater than or equal to x squared minus 4, and then x minus y is greater than or equal to 2. All right, so what I'm going to do is graph each of those inequalities. So I'm going to get my coordinate plane ready. Okay. All right, so I'm going to think about the equation y equals x squared minus 4. So that's a parabola that opens up, okay? That parabola right there is going to equal 0 if x squared equals 4, so x would equal plus or minus the square root of 4. So 2 plus or minus 2. So that tells me that that parabola is going to cross the x-axis. So the y equals 0 when x is plus or minus 2. So I know that's the case. I also know the y-intercept is going to be 0, negative 4. And that's also the vertex. So really I can just do this, you know, finding some ordered pairs. So I could put a 0 here, and I would get both 2 and negative 2. And if I put a 0 in for x and plug it in, then 0 squared minus 4 gives me negative 4. And then knowing it's a parabola because it has that squared on it. So it's going to wind up being a u that does something like that. This particular one, let's see, that particular one has an or equal to, so it's going to be a solid line. Let me make this one just greater than rather than greater than or equal to, so that we can talk about that. All right, so if it's got an or equal to, it's going to be solid. Now, before I leave that parabola, I need to decide whether to shade, you know, above it, like in the middle here, or outside of it over here and here. So you do that by just picking a test point. So on that one, I'm going to see if 0, 0 is a solution. But you can use any ordered pair as long as it's not on the parabola. And I'm just seeing if it's a solution to the inequality that I was dealing with, this inequality. So put in a 0 for x and a 0 for y, and you get 0 is greater than or equal to negative 4. So that's true, isn't it? 0's to the right of negative 4. So you're asking that question, and your answer is yes. So that means you're going to shade in here. Okay. All right, but don't shade it yet. Just know that that's the case. All right, now let's work on the second one, this guy here. So we're going to look at x minus y equals 2. When we do graph it, it's going to not be solid. It's going to be dashed because I took off the or equal to on that. So this is a line. There's no squares on anything. So I might just graph this one by looking for ordered pairs that satisfy that. So wouldn't 4 minus 2 be 2? Wouldn't 3 minus 1 be 2? I could put in a 0 for y and get a 2 for x, or a 0 for x and plug it in, and then y would have to be negative 2. So you don't need a bunch of points. You really just need 2, and you're going to graph that. So here's 4, 2. Here's 3, 1. See the trend? There's 2, 0. Here's 0, negative 2. And when I connect them, they're going to be dashed. Right? So before I leave that one, I need to decide whether I need to shade inside or outside. So for this one, I'm going to see if, and 0, 0 would work, so I'm going to use it for this. If 0, 0 is a solution, see if it works in this inequality. So put in the 0 for x and y and see if you get something that's greater than 2. Is 0 greater than 2? No. 2 is bigger. So that means 0, 0 doesn't work. So here's my line. Here's 0, 0. And 0, 0 doesn't work, so I have to shade this way. Okay. So your final answer would be where you have the blue arrows, right? So you got to be inside the arms of the parabola and below the line. So your final answer, I'll do it in purple, would just be these guys right here, where both colors point into the same region. Okay. All right, and then I want to do one more, and that would be polynomial inequality. Actually, I'll do 2 of that one. So that's section 3.6, one of the last sections we did. Let's see if I can get my cursor where I want it to be. Where are you, cursor? There you are. Okay. All right, so this is from 3.6. Let's do 2 of them, and then you can continue working on your either take-home test or getting ready for your final. All right, so let's suppose I'm trying to do this guy. All right, so this is an inequality that only has a single variable in it. So my answers are just going to be x's that make that work. So what I'm going to do is I'm going to find out what causes 2x squared plus 9x plus 4 just to strictly equal 0. All right, so this one might factor. I would need a 2x and an x, and if I put a 4 there and a 1 there, that should work if I make them both positive, and it does. And so then I can tell that either that factor has to be 0 or this one. So x equals either negative 3, or here I would subtract 1 and then divide by 2 and get a negative 1/2. Okay? So what those are the numbers that are the boundary between the numbers that work and the numbers that don't work. Okay? Now, whether you put an open or a closed circle on those depends on whether you had an or equal to or not. This one had an or equal to, so it's going to be closed circle. So these are going to be solutions themselves, but they're not the only solutions. Then your job is to decide whether to shade inside or outside. So here's where you can just pick a test point in each of the regions, like a negative 4, and you plug it into the inequality to see if it's a solution. So is 2 times negative 4 squared plus 9 times negative 4 plus 4 bigger than or equal to 0? That's a question you're trying to figure out. So 2 times, this would be 16. So that's 32 minus 36 plus 4. So that turns out to be, oh, I made a mistake somewhere because that shouldn't equal 0. Oh, I see where I made the mistake. Right here, x plus 4 equal to 0. That should be negative 4. Okay, that's why that gave me that it equaled 0. So it's not negative 3 that's a solution, it's negative 4. Let me redraw this so I can move it over a little bit. All right, so the two solutions were to the equation were negative 4 and negative 1/2, and because of the or equal to, those are part of the solution. So really I need to test something outside of those. So not the negative 4, I'm going to test a negative 5. All right, so if I put in a negative 5 everywhere, okay, everywhere there was an x, and see if it works, I'd get 2 times 25, that's 50, minus 45 plus 4. So that's a positive 9. That is bigger than or equal to 0. So my answer would be yes. Okay, so that means that is a solution. All right, now if you don't understand, if you didn't superimpose a parabola on top of this, then what you would need to do is test whether something in the middle works or not. So like a negative 2. So you'd plug in the negative 2 and see if it's bigger than or equal to 0. So that would be 2 times 4, which is 8, minus 18 plus 4. So that would be negative 10 plus 4, that would be negative 6, and your answer there would be no. So 2 is not a solution. And then you'd pick something to the right of this negative 1/2, like a 0, and test 0 as well. And when I test the 0 and I put it in, then I'm going to get a 0 for the first term, a 0 for the second term, and then 4, which is greater than or equal to 0. So it's a yes. Okay. So what I was trying to convey to you in class is that even though this didn't have a y in it, I like to wait till now to do it, because what I could do is think of it as a parabola. Y equals 2x squared plus 9x plus 4. And if this were really a coordinate plane where I had like an x and a y axis, these 2 points you found would be where the parabola crosses the x-axis. And because the a value is positive, we know it opens up. Okay, so it would do something like this. Okay, and if you want to know where is your y bigger than or equal to 0, y would be greater than 0 here, y is less than 0 there, and it's equal to 0 right on the x-axis. And if you want to be greater than 0, you'd need to be on that part of the parabola or that part. So that's why when you smash these points to the x-axis, it's going to be outside each of those. Smash these ordered pairs. Find what the x's of those ordered pairs are. And what you see is that your solution to this needs to be all these spots to the left of negative 4 and all of these to the right of negative 1/2. All right, so it's outside. So if you know that and you've tested negative 5 and you find out it works, then you know it's outside, and you can just go ahead and go from there to write what your solution is. Okay, so your solution to these would be written in interval notation. Try to get a little more paper here. Okay, so we're going to write our answer in interval notation. So it would be negative infinity until I hit negative 4. And because it was or equal to, I'm going to use a bracket. All right, and then over here, this interval would be from negative 1/2 all the way to positive infinity. So my answer to this would wind up being those two put together with a union symbol. Negative infinity to negative 4, union negative 1/2 to positive infinity. So since the parabola opened up, okay, and you wanted to know where it was greater than 0, it wound up being outside. Okay. All right, let's do just one more. And how about if we had one that had a less than on it? So what about if we were trying to solve this? X squared minus 4x is less than 0. So we're just trying to solve it. We're not trying to do any kind of graph. It's not an equation in two variables. All right, so there'd be a two-part process. You'd look for where it's equal to 0. And since it's quadratic, you could factor out the x. This one didn't turn out to be two binomials. You factored out the x. Now you're going to set each of those factors equal to 0. And when you do, you get x equals either 0 or 4. Okay, so that means you know the boundaries, that those are going to be the places where this function would equal 0. All right, so think about this. That means, again, this parabola would open up, since it's positive out in front, right there. And you want to know where it is less than 0. Here's where it's equal to 0. So you want to be down here. So you want to be there. So you would know that it needs to be in between 0 and 4. Now this particular one didn't have the or equal to on the inequality. So these would have been open circles. And I would want to be in between those. And so I would have the interval from 0 to 4. And that would be my final answer. Now, if you didn't want to think about the graph, you don't have to. You could do this, and you could just test. So these are the spots. You know they're open circles because it wasn't allowed to be equal. And then you could test something in the middle of the two values, or something in between the two values, and then a number outside. And you test it in the inequality. So see if -1 works. Okay. If you plug in a -1, do you get something less than 0? Well, this would be 1. That would actually be +4. Is that less than 0? Well, no. So it's not there. And then if you understood that this is a parabola that opens up or down, you know, you didn't have to analyze everything, but if you knew it was a parabola situation, then if it doesn't work outside, you know it has to be inside. Or you can do it less thoughtfully and just plug in a 2. It's just more work is all. If you know what you're doing, you have less work. So that's 4 minus 8. -4 is less than 0. So that means this is a solution. And then if you plug in a 5, you'd get 5 squared minus 4 times 5, which would be 25 minus 20. And that's not going to work. And so we'd get this right here. And then we'd go write it in interval notation.